So coming to problem set 3, standard 10th geometry. The first question they have asked is, two circles are of radii 5.5 and 3.3 respectively touch each other. Okay, they touch each other. What is the distance between their centers? Okay, the distance between their centers. Okay, so there are two possibilities. Either the circles will touch externally or they will touch internally. Okay, when the circles are touching externally, the distance between their centers will be 5.5 plus 3.3. Okay, which comes to 8.8. Now here the question they have not given that whether the circles are touching internally or externally. So we will have to take both. So here internally touching circles, if you see, this is 5.5, this is 3.3. So 5.5 minus 3.3 comes to 2.2. So which option you will have? The D option. It can be 8.8 or 2.2. Okay, coming to second one. Second one says that two circles intersect each other such that each circle passes through the center of the other. Okay, so if the distance between their centers is 12 centimeter, what is the radius of the each circle? Now let us try to understand what is the first sentence given. Two circles are passing through the center of each other. Okay, so it means the second circle I'll be drawing will be passing through here, and this is the center of the other circle. So if this is the radius, okay, are you getting? So it means these two circles are passing through the centers of each other. Does that mean their radius will be equal? Yes, they will have same radius. Okay, they will be congruent circles. Okay, and we are given that the distance between their center is 12 centimeter. That means their radii is also 12 centimeter. Okay, what is the radius of each circle? So it will be second one, that is 12 centimeter. Okay, this is only for your explanation. You just have to take the correct option. Okay, coming to sum number 3, they have given a circle touches all the sides of a parallelogram. Okay, so the parallelogram must be a, okay, when it touches all the sides of a parallelogram, it must be a, of course you know the property, when all sides are equal, rhombus. Okay, a rhombus is itself a square. Okay, a square is a rhombus. So when you take a rhombus, that means square is also included in it. Okay, fourth one says that length of tangent segment drawn from a point which is at a distance of 12.5 from center is 12 centimeter. Okay, so we understand that there is a point outside circle and the length of tangent segment drawn from a point outside the circle, okay, which is at a distance of 12.5 centimeter from the center. So this is 12.5 centimeter away. Okay, and it is how much? It is 12 centimeter. Okay, so we are asked to find the diameter of the circle. Now we cannot find diameter directly, but we can find OB. Yes or no? OB is actually radius. Okay, so once we find the radius, we can find the diameter. How will we find the radius? R square. See, this is 90 degree. So it is hypotenuse square minus other side square. Okay, hypotenuse we know, other side we know, so we can find r. So I'll be doing this with a square minus b square. So a plus b and a minus b. Okay, 12.5 plus 12 is how much? It is 24.5 and this is 0.5. Correct? So 24.5 into 0.5. So it will be 245. 5 are 5 5 are 25. 5 4 are 20 plus 2 22. 5 2 are 10 plus. This is 12.25. R square we are getting 12.25. So how much will be R? R will be, you know, the square root of 1225 is 35. So R will be 3.5. If R is 3.5, diameter will be twice of 3.5. So that is 7. So we are getting the C option as the correct option. Then, okay, fifth one is a two circles are touching externally. How many common tangents of them can be drawn? When two circles are touching externally, it means we will have only one common tangent. So your correct option is, beg your pardon, we can draw one from here also. This is a common tangent and this is also a common tangent. Okay, so actually we can draw three common tangents, okay, for two externally touching circles. Then question number 5 given is angle ACB is inscribed in arc ACB. Okay, so I am drawing this arc ACB of circle with center O. Okay, so now let me draw this like this, ACB. Okay, so it is given that angle ACB is how much? It is 65 degree. So find measure arc ACB. Okay, how will you find measure arc ACB? Very simple. See, this is question number 6. So if this is 65, this arc, the intercepted arc, will be double of 65. So it will be 130. You know inscribed angle theorem. Okay. Now they have asked arc ACB. Okay, this arc. So it will be 360 minus this arc 130. Okay. So what is 360 minus 130? It is 230. So your D option is the correct option. This is only for your understanding, rough work. Okay. Then seventh one given is chord AB and CD of circle intersect at point E. Okay. So they intersect inside the circle AB and CD. They intersect at point E. Okay. Now, because they intersect at point E, you know the property of intersecting chords. Okay. We'll have AE into EB is equal to CE into ED. Yes or no? This is the property of intersecting chords. Now, measures are given. AE is 5.6. Then EB is 10. Okay. CE is 8. And you have to find ED. So very simple. I'll substitute this. 5.6 into 8 is equal to 8 into ED. Okay. Now, okay, so I'll just correct this. EB is not 8, EB is 10. Okay, so you have now ED is equal to 5.6 into 10 becomes 56. 8 will come below. Okay, so 8 ones are 8 sevens are. So how much is ED? ED is 7. So your option A is the correct option. Okay. Question number 8 given is quadrilateral ABCD is cyclic. Okay. And twice the measure of angle A. Because ABCD is cyclic, I will write angle A plus angle C equals to 180 degree. This is one equation. And they are given twice the measure angle A is equal to thrice the measure of angle C. Again we'll do, come on. Twice the measure of angle A equals to thrice angle C. So 2 angle A equals to thrice angle C. This will give me another equation. If I bring this here, 2 angle A minus 3 angle C equals to 180. Sorry, this is 0. Nothing is here. So it is 0. Okay, so we got another equation. See, this is 1 and this is 2. So simultaneously, if I solve, if I want to make this 3, okay, let us multiply this by 3. 3 angle A plus 3 angle C equals to 18 3 is 54. So we are getting this. Now if I place this below, 2 angle A minus 3 angle C equals to 0. So what will happen here? Angle C, 3 angle C minus 3 angle C becomes 0. This is 5 angle A, correct? Equals to 540. Okay. So angle A, just a moment, this is 3 angle A, correct. Okay, so 5 ones are 5, just a moment. So angle A is 540 upon 5, which is 5 ones are 5, 5 zeros are 0, this is 5 eights are 40. But we don't want angle A, they have asked us what is angle C. Okay, so if you see angle A plus angle C is 180, so angle C will be 180 minus angle A, 108. So it will be how much? 72 degrees. So your answer is 72 degrees. Second option. Okay, then coming to sum number 9, they have given points A, B, C are on circle such that measure arc AB is equal to measure arc BC. Okay, so A I am writing here, C I am writing here. This arc is equal to this arc. Okay. Now, such that each of them is 120 degrees. So I am further writing here, this A I am taking here and C I am taking here, because 120 means 1/3 of the circle they are covering. 360 makes full first circle, so 120 is 1/3 of the circle. So they have asked which type of triangle is triangle ABC. So I'll first draw triangle ABC, and if this is 120, this is 120, this is also 120. Okay, so all three are 120. Okay, now because all three are 120, this triangle, okay, becomes an equilateral triangle because all three sides will be congruent to each other. Very simple. Okay, coming to sum number 10. So coming to sum number 10, they are given sec xz is the diameter of the circle, point y lies in its interior. How many of the following statements are true? Okay, so I'll take this xz is diameter, y lies in the interior. Okay, so you know that first one, it is not possible that angle XYZ is an acute angle. Okay, I think so it is correct, because it cannot be acute, it has to be obtuse. When an angle has one of its side has diameter and point is in the interior, it is obtuse. When the point is on the circle, it is right angle, and when the point is outside the circle, it becomes acute. So you have to remember acute, right, and obtuse depends on where this point lies. Okay, so first statement is correct. Second, angle XYZ can't be a right angle. Very true, it can't be right angle, it is an obtuse angle. Okay, third one, can't make a definite measure statement for measure of angle XYZ. Uh, Third one is angle XYZ is an obtuse angle. Third statement is also correct, it will be an obtuse angle. Then fourth one, can't make a definite statement for measure of angle XYZ. Yes, it is an obtuse angle, but we cannot find out how much. Obtuse angle is from 91 degrees to 180 degrees. So it can be anything. Okay. So how many statements are correct? Okay. Here only 3 statements are correct. The above 3 statements are correct. So it is third one. Okay. Let us come on to question number 2. Question number 2 has 3 sub questions under it. Okay, and the given information you can read, the radius of the circle is 9 centimeter. So first question is very easy. They have asked what is distance OP. Okay, distance OP is, you can see, radius of circle is 9 centimeter. Therefore distance OP is equal to 9 centimeter. Very simple. Okay. Second one they have asked is distance OQ is 8 centimeter. Okay. Distance OQ is 8 centimeter. So where does point Q lie? Very simple. Radius of circle is 9 centimeter. Anything which is less than 9 centimeter will lie in the interior of the circle. Okay. So distance OQ is less than radius. Therefore, point Q lies in the interior of the circle. Okay, then coming to question 3, they have asked distance OR is 15 centimeter. You have to correct it in the textbook. Textbook they have given PQ is 15 centimeter, but it is not 15 PQ, it is OR. Okay, you can correct in the textbook. So OR is 15 centimeter. You can see this is 9 centimeter. So at what distance will each of them be from point P? Okay, so very simple. I'll first write OP is perpendicular to PR. Why? Because tangent perpendicular to radius. Okay, now we'll start. In triangle OPR, angle OPR equals to 90 degrees. Okay, therefore OR square is equal to OP square plus PR square. This is by what? This is by Pythagoras theorem. Okay, so I will write this 15 square is equal to OP square plus PR square. So PR square will become 15 square minus 9 square. So it is 225 minus 81. What is 225 minus 81? It is 144. Okay. So if PR square is 144. What will be PR? PR will be equal to 12. Okay, so each location of point R will be 12 centimeter from will be 12. Okay, 12 centimeter from P, whether it is R or R1. It is the reflection image of R1. Okay, very simple. Let us move on to question 3. Coming to sum number 3, it is given that KL is tangent to the circle and segment KL is 6 root 3. You can see MK is 12 and ML is the radius. Okay, so first thing we have to find is the radius of circle. So we can find it by Pythagoras theorem. Okay, so we'll write first ML is perpendicular to LK. Why ML is perpendicular to LK? Radius perpendicular to tangent. Okay, now in triangle MLK, angle MLK equals to 90 degree. First you have to mention this and then write by Pythagoras theorem, hypotenuse square is equal to one side square plus other side square. This is by Pythagoras theorem. Okay, so MK is 12 square is equal to ML square plus 6 root 3 square. Okay, so ML square is equal to 12 square minus 6 root 3 square. This will come here. 12 square is 144 minus this becomes 36 into 3. Correct? 6 square is 36, root 3 square is 3. 144 minus this is 108. So how much will be ML square? It will be 36. Okay, so ML square is 36, so ML will become 6. Okay, so now we got ML as 6 and we are asked to find angle K and angle M. We are done with the first part. Let us come to the second part, finding angle K and angle M. So angle K and angle M, if you see this, okay, MK upon ML if I take, it is 12 upon 6. Okay, which means it is 2 upon 1. So I can write MK is twice of ML. This is cross multiplication. Okay, now why I am doing this? Because in a right angle triangle, this becomes a right angle triangle. You know this is a right angle triangle. In a right angle triangle, hypotenuse is twice of one of the side. When this happens, hypotenuse is twice of one of its side. That means this side is side opposite to 30 degree. Okay, so this is therefore by converse of 30 degree, 60 degree, 90 degree, angle K equals to 30 degree, because its side opposite side is half of hypotenuse. You know by 30, 60, 90 theorem, side opposite to 30 degree is half of the hypotenuse. So now we are getting one side is half of the hypotenuse. That means its opposite angle is 30 degree. Correct? Now, you know we have got the type of the triangle now. This triangle type is 30, 60, 90. So once we get angle K, it is very easy to find angle M. So in triangle KLM, I'll write angle K equals to 30 degree. This is from 1. Angle L equals to 90 degree. Okay, therefore angle M will be how much? It will be 60 degree because it is the remaining or third angle. Okay, so very easy, it will be 60 degrees. Okay,